Good morning, all. So today we are going to look at the buffer analysis. So normally, the buffer analysis we are doing the purpose for like to get the distance from the origin locations. So origin locations mean like if you have a locations like home, hospitals, uh, divisional secretariat office, and some land users. So from those location, by using the distance, we made the buffers. So now I'm going to show the how we can create the buffer using this arc map. So you know how to add the layers, I mean the shape files or feature classes. So using the folder connection, hope you may understand those things already. Using this folder connection, I had some layers, so I'm going to add these layers for your purposes to do this buffer analysis, right? So now I'm going to add these point locations. All right, so when you do this buffer analysis, you have to consider two things. Normally, the coordinate system. There are two coordinate system. One is geographic coordinate system, other one is a projected coordinate system. So when you consider about this projected coordinate system, that is actually the flat surface. So normally for the flat surface, the buffer is getting analysis by x and y coordinates. So two dimensions. So most probably we are using that x and y, the two-dimensional coordinate system to get these buffers compare with the 3D dimensional. All right, for this 2D buffer analysis, normally the technique is that the flood mean like normally we have the coordinate system, projected coordinate system. So I hope you know already Kandawala Sri Lanka or SLT99. So with that, we can do the flood surface buffer analysis. All right. For this, the Euclidean distance, you don't want to think about that one. So it means you just understand the flood surface, only the flood surface, x and y. So if we are doing the buffer from one location, you have two options. You can do the buffer by using two methods like 2D and 3D dimensional. Right? For the 2D, the technique is Euclidean distance based distance analysis. For the 3D, the geodesic. It means sorry, the surface is globe when we go through in a 3D dimensional. So the distance also it has a curve. It's because of the globe. All right. So that we call the geodesic method. It comes to get this buffer analysis for the 3D dimensional. But normally we are using the two-dimensional 2Ds. So x and y it's flat. So Euclidean distance. It means like it's normal. It's from one location to other locations normal distance. We are measuring by meters, feet. So those are measurements we are using for that distance. So now I'm doing this buffer. to get more understand by you. All right. So you know this environment of this arc map setup. So this is this geoprocessing tool. So you can just click this geoprocessing button, and when you click it, you can have the pop-up like this toolbox. So now I just move this toolbox and keep it in this right side arrow, then it will fix the frame in this way. So now you have the search option in the right side. If you don't have, you can see the search, that is easy. You can search the search button here. So when you click it, the search button will pop up in your right side window. Then you can search buffer. So now you can see the buffer analysis. So when you click the create buffer, like in the middle link, you can have the idea about what is the buffer, right? So it's simple. So you can, if you want to get more idea, you can read that one. And when you click it here, it will direct you. So when you click it on top of this buffer analysis, it will direct you directly to the parameters, the Python parameters frame. Okay, I will try to show that you can straight away go to the buffer analysis without searching if you have more practice with this software. So now I am going to straight away select this buffer analysis. So normally you will get the window, the buffer parameters you are going to enter. This pop-up window you will receive once you search and find, or like you can straight away go to um, toolbox and get it. Okay. So for the input feature parameter, I'm going to give the location, this one, location shape file. So in this way you can input your location data into the buffer parameters frame. So here you can design or you can direct the location where you want to save your output, this one. So you know how to direct this one. When you click this button, it will direct you where you want to save your output works, right? So for time being, I keep the default geodatabase. Then the next parameter, you can see the distance. You can see the distance. So in this distance, it's because of this save file, you can see the property and go to the source.